All right, good morning, everybody. Thank you for attending Long's annual weekly coffee break. This has been going on for about 2 years now. So before we get started, I just really wanted to send out a thank you for everyone that joins weekly, because you're the true reason that we're able to keep doing this really neat educational thing that we started during the depths of the pandemic. My name is Cutter Ballant, and I am a sales engineer with Long. And today I have with me Jim French and Lance Patterson with Distech Controls, one of our building automation partners. And today our topic of discussion is the smart air control valve that Distech has recently released. Short for that is SACV. So first, I'm going to go to Jim here. And Jim, I was wondering if you could kind of take us through what VAV design changes have happened over the last 50 years, if any.
Very good question, Cutter. And first, thanks for having us this morning. I appreciate the opportunity to share some new innovation with you. The VAV systems were introduced to the market back in the late 60s, early 70s, and really nothing has evolved substantially in any innovation within that mechanical system design. They initially came to be as to replace constant volume systems as a more energy efficient design. With the thought behind it, they can vary the airflow into the space for heating and cooling purposes based on the load. And as the load decreases in the building, you can back off on the fan horsepower, creating that variable airflow. The VAV terminal unit is the most prevalent component of any mechanical system design, and you'll find that anywhere from 20 to 60 boxes can be installed on a single air handler. Often there's buildings with multiple VAVs in the buildings that include hundreds or even thousands of VAV terminal units. And each one of those is specifically sized for the space that it serves and the thermal load that's within. And so that requires a whole bunch of different sizes of terminal units. And it's a very complex design process for mechanical engineers to go and put these designs together because of the limitations of some of these terminal units we'll describe for you in just a second. A couple of other things about it, Cutter, it requires static pressure in the supply riser. Many of these systems require 1 inch to 3 inches of pressure to operate. And with pressure comes noise. And acoustics are a challenge with these systems, and keeping the noise in tolerable ranges for customers. And then often the systems are balanced at the time of install, but very rarely do you go back a year later or even several years later and look at the balance of those systems and still check to see if they're performing to their optimum point. In many cases, they're not, and they're just consuming additional energy, and then they're costing extra money that they shouldn't have to.
Thank you, Jim. Yeah, that last point there. Often when we all go into buildings, it's very rare that you see a building get rebalanced after TIs are built out. And as we know, typically within a year, a building is out of balance on both the air and the water side. So a lot of good points there. The next slide, Lance, I'm going to ask you if you could help us kind of go through some of the differentiators between a traditional VAV box and what we're talking about here today with the smart air control valve.
Yeah, you bet. Thanks, Cutter. And I'll mimic what Jim said. Thanks for having us on. We appreciate it. It's a great opportunity to speak to your customers. So yeah, if you really look at the SACV compared to the traditional VAV market, really the bottom half of this slide kind of tells a lot of the story. If you look at the accuracy between 200 to 2,500 feet per minute, we're plus or minus 4%, which is incredible accuracy. But where we start looking below that, that really tells most of the story, where we can get down to 25 feet per minute and still maintain an accuracy of plus or minus 8 feet per minute. That's pretty low airflow, pretty low velocity. The minimum air pressure that we're looking, or the velocity pressure that we're looking for coming in is 0.03 inches at 25 CFM. We're able to achieve some really amazing turndown ratios. If you look at the 100 to 1 versus 4 to 1, it's incredible, you know. And what all this really tells you is the box size availability. Because of that 4-to-1 turndown ratio, the traditional VAV really needs a variety of different sizes. You can see there 4-inch all the way up to 16-inch, and sometimes dual VAVs as well to achieve higher flows. When we look over at the SACV, it's really only 2 sizes, especially on the round side, and then 2 sizes on the rectangular side, because we're able to take a 12-inch VAV and still ramp up to 2000 CFM, but ramp all the way down to say 25 CFM. So we can achieve some incredible turndown, which allows us to have, you know, less SKUs, if you will, less product to have to choose from, which we'll explain some of those benefits in a couple of slides as well.
Thank you, Lance. I appreciate that. And then Jim, on the other side of the market, as we shift into healthcare and lab type spaces, so hoping you'd be able to touch on a few points here. And then also Lance was mentioned that turndown ratio, if maybe you could go into how that is exactly achieved, and also maybe touch on ASHRAE 195 briefly as well.
Sure will. In fact, I'll try to do it in reverse order a little bit.
Right.
ASHRAE 195 is a standard that's being promoted primarily by the VAV box industry to have the controls, the actuator, the flow sensor all tested as a complete assembly before it leaves the factory. And just as any packaged unit would have a complete test kind of associated with it. That would preclude us from field installing our control bundle if that was specified onto a project, for example. But there are ways to get around that. You can factory mount controls, and you saw the previous slide that most manufacturers for a nominal fee will mount anybody's controller on their box, and you can meet that requirement. The SACV is an ASHRAE 195 compliant device because it does come factory tested, complete, commissioned, pre-balanced as a unit right out of the factory. And so that is an advantage to this. It simplifies the install and the startup of the mechanical system in general. As you can see here, we're achieving a lot less inlet pressure than traditional systems. In this chart, we compare to Venturi valves or the Triatech. We even have the new Siemens GOLO in comparison on this chart. The GOLO is the predecessor in technology to the smart air control valve. Previous technologies, again, limited in turndown, their turndown ratio 15-to-1. They advertise a 0.3-inch inlet pressure minimum. However, most of these valves require at least an inch of pressure across the valve to get it to accurately perform. And what we're talking about here is all the way down to 0.02 inches on the high accuracy version of our valve we're going to be releasing here over the next few months to address the lab and the healthcare space. How we're able to do this is through what's called variable orifice plate technology. As opposed to traditional systems, they measure the velocity and the static pressure at the same point of measurement in a flow ring. In this case, this technology, we use the single blade damper in the product itself as the orifice plate, and we pick up our substatic pickup actually behind the damper shaft itself. Using that technology, we're actually able to achieve 100 times magnification of the flow signal and give us that turn down capability to be able to read and measure, accurately control to low flows at a very low velocity.
Excellent. Thank you, Jim. Appreciate you explaining that. On this next slide here, Lance, would you please entertain us here and kind of go over as to the end user and mechanical engineer, as well as the mechanical contractor, kind of what some of the unique properties of the SCAV are for the audience.
Yeah, definitely. So, I mean, this slide here kind of does kind of a brief review of some of the things we've talked about, you know, the 100-to-1 turndown ratio, or, in the case of the life sciences version, if you will, 300-to-1 turndown ratio. But some other features to point out, we're only having a 1.5 CFM leakage in this damper, which is really great. We have an aerospace damper gasket that's non-seating, so you can be sure that no matter how many times you close off that damper, it's not going to seat that gasket, which is really nice. The high accuracy feedback from the actuator is fairly unique. Our VAV controller actually has an embedded actuator with real-time feedback, not just a, say floating point or some sort of guesswork that we have to keep zeroing out. We're actually getting real-time feedback from that actuator, so we know exactly where that damper is actually going to be seated. And then as well as factory installed discharge air temperature sensor and hot water piping package. So if you go to the next slide, those two will really speak to some of the benefits from the mechanical contractor, the consulting engineer, the end user. The end user, what we can expect is a 10 to 20% energy reduction. So we're going to really optimize that energy. Flexible space, which is really cool as well. Because if you think about some of the office spaces these days, the open flex office spaces, as soon as you put up a wall somewhere, what generally has to happen? We typically have to take out whatever existing VAVs in that space, and we have to resize it for the new space, right? But when we're able to achieve 100-to-1 turndown ratio on a VAV box, we don't necessarily need to rip out that VAV box anymore. We can simply just reset the airflow minimum and maximums to be able to accommodate the new space that is now in with the addition of walls and whatever the case may be. Because we're able to achieve lower velocities and lower static, the noise reduction is a big factor for an end user. We've all been in those buildings where you'll hear the ductwork shaking and you'll hear physically the airflow going through some of that duct. So that noise reduction is decreased. From a consulting engineering standpoint though, the noise reduction is another big one because we don't necessarily need that sound abatement anymore designed in the system. So the design gets simplified. From a simplicity standpoint of the design as well, though, I've talked to consulting engineers and the big thing that they see is the fact that they don't have to go through a book full of SKUs anymore to select all their VAVs because we've simplified that process by not needing that many sizes of VAVs because of that turndown ratio. And then from a mechanical contractor standpoint, again, the noise reduction and the no need for sound abatement, if you will, that's a big thing for them, as well as the prepackaged assemblies that we're able to put out. So we're talking about big labor savings and the fact that when we have fewer sizes, if we can size every VAV box the same, the job deployment itself actually gets a little more easy as well, because in some cases, if we misorder a size of a VAV, what do we have to do now? We have to reorder and then wait for lead times and whatever the case may be. And if everything's the same size, it makes the installation a lot more simplified. Jim, is there anything that you wanted to add to that as well?
I just wanted to highlight the point that from an air balance perspective, these things are factory calibrated devices as well. So there's no K factor in the valve itself for adjustment purposes. It is highly accurate right out of the factory. The controller is pre-commissioned. It comes ready to go into service. Effectively, a system integrator would just need to address the device and integrate it into a building management system if that's required. It's certainly capable of running in a standalone mode with a variety of the Distech sensors. The sensor line that we provide can be plugged right into this device, and you've got options for temperature, humidity, CO2, etc.
Yeah, great point, Jim.
Thank you, Jim. Thank you, Lance. So to summarize what we talked about here today, really three categories. First being the owner. Sounds like we have a lot of potential for energy savings, as well as the flexibility of future TI work. Really reduces our total cost of ownership of a building down the road. Then from design engineer perspective, hearing you guys say that greatly reduces the amount of time that it takes to design a floor plan due to the lower amount of SKUs and the flexibility that this box offers, valve offers, with that high turndown ratio. And then on the mechanical contractor side, sounds like we're getting to a place where instead of having to run 8 different sizes of duct, we really streamline our installation process for the guys and gals on the boots on the ground actually putting this stuff in. So thank you all so much. I really appreciate everyone joining today. If you have any further questions, contact your Long sales engineer and they will be able to assist you. Next week, Lindsay Flater will be presenting, and she will be talking about the ease and features of Blue Duct. Thank you all and have a wonderful day.